Now, you may have picked up in the last couple examples that one of our strategies, or overall strategies, has been tried to, one, work on the more difficult side. And the one that I haven't really explained, but I've just done, is I've always tried to reduce it to sines and cosines. And from there, I try to continue on with the problem. But here, everything's already in sines and cosines. So what do I do? Well, one thing I'll probably do on this one is, let's just start with somewhere and see where it goes. So let's look at the left side. To me, that's a little bit more complicated because it has a summation in the denominator. So I tend to see those as a little bit more complicated. I'm going to multiply that by a clever version of 1. The clever version of 1 I'm going to choose is 1 minus the cosine of x all over 1 minus the cosine of x. And so doing what I see, and let me put parentheses around that so that doesn't interfere. I have the difference of, well, what will appear to be the difference of two squares. Remember that? Always comes back to us. So the denominator is 1 minus the cosine squared of x, difference of two squares. And on the top I have sine of x times 1 minus cosine of x. All right, don't know if I'm much farther along, other than this 1 minus cosine squared of x. That sounds or seems familiar to us somewhere. Only where did I know that from before? Oh yeah, over here again, I love this sine squared of x plus cosine squared of x equals 1. Let's solve this one for sine squared of x, which means I subtract cosine squared of x from both sides. And I'm left with sine squared of x equals 1 minus cosine squared of x. So this right here, the denominator is sine squared of x. And on top I have sine of x times 1 minus cosine of x. Looks like what I'm able to do is I can eliminate one sine of x on the top and one on the bottom. And then I'm left with 1 minus the cosine of x all over just 1 sine of x. And let me just show you kind of what I did there. That might have sounded like something kind of cool that happened. So let me rewrite this a little bit right above it over here. So I have sine of x times 1 minus the cosine of x all over sine squared of x. Well, that's the same thing as the sine of x times the sine of x. Now do you see what happened? Then what I did is, this is a clever version of 1 right here, so I cancel those two out. And then what's left with is just 1 minus cosine of x over sine of x, which was what I was trying to verify all along.